Well, I must say it's a real pleasure to finally be up on my hind legs on the stage here, having enjoyed this conference right back to the very first one. And as Hugh said, my background's physics and astronomy. I worked for English Heritage at Stonehenge for a number of years when I was able to abuse my staff privileges at certain stages to get access into the monument to do some observations that wouldn't ordinarily be able to be done. So let's kick off. This is the astronomy of Stonehenge. Well, some of it, because the topic is enormous. And I could easily keep you going for about 2 days if you weren't allowed to escape. A lot of people who've done the astronomy of Stonehenge start off with a plan of the monument and they draw lines all over it. And there's one of my first attempts at working out what was going on. That's an orthographic projection to work out the solstices, the lunar standstills, and all the rest of it. But to really pay attention to what's going on, you need to look at the landscape, you need to look at the shapes of the stones, and you need to pay more attention than just the lines on the map. So the astronomy of Stonehenge is quite controversial, and for about 60 years, we've had this new sort of subject area spring into existence called archaeoastronomy. And as Ed Krupp of the Griffith Observatory says, archaeoastronomy is a word with too many vowels. He's quite right. And archaeoastronomers do not go around digging up old telescopes. We don't do that. But why do we think that Stonehenge has any astronomy at all? It may seem obvious now, but we've got 60 years of thinking about it. But prior to that, not so much. We'll have a look at why we think. So perhaps the best place to start is getting on for 2,000 years ago with this quote from Diodorus Siculus, which is an extract from Hecataeus of Abdera's work on the Hyperboreans. And many of us will be familiar with this. We've got a land opposite the Celts, inhabited by Hyperboreans, the ultimate northerners. And I'm a Scouser originally, so it's not quite ultimate northerner, but nearly. And you've got a magnificent precinct sacred to Apollo, god of the sun, and a notable temple of the spheres. That's sometimes translated as spherical temple, but temple of the spheres is a better way of putting it. And it goes on to discuss that the moon comes very close to the island every 19 years or so, and the god plays on the lyre and dances, yada, yada, yada. So that's 2,000 years ago, and then nothing. That's arguably about Stonehenge. It could be about Callanish, but it's about something going on in the ultimate north. By the time we get to the 18th century, Dr. John Smith, the renowned inoculator of the smallpox, wrote in his catchily titled book, Quire Gar, the grand orrery of the ancient Druids, commonly called Stonehenge on Salisbury Plain, astronomically, it's great for a pithy title, says the apex of stone number 1 points directly to the place of the solstitial sunrise. So he's talking about the heel stone. That's what he named stone number 1. And he wrote that in 1771, and he's completely wrong. He pinched the idea off William Stukeley, who got it right. 30 years earlier, he noticed that it's the avenue that points to the solstitial sunrise. And the heel stone's actually off-center from the avenue. So Stukeley writes that the avenue answers to the principal line of the whole work, the northeast, whereabouts the sun rises when the days are longest. And to us nowadays, that seems very obvious. You know, people gather in their thousands at Stonehenge in the middle of June to watch the sunrise down the avenue over the heel stone. But prior to that, it really hadn't been remarked upon. And that's quite curious. Until you remember that there's a change between the Julian calendar and the Gregorian calendar. Prior to that shift, although there was a fair at Stonehenge at midsummer and had been going on right back into the medieval time, it was held on traditional Midsummer's Day, June the 24th. And before we made the shift to the Gregorian calendar, and still on the Julian calendar, the actual day of solstice in the Julian calendar was June the 10th. So if you're rocking up for a fair on the 24th of June in that calendar, you're after solstice. So the sun isn't rising down the line of the avenue, it's off to the right of the Heelstone somewhere. And that makes it even more remarkable that Stukely was able to spot that the avenue was what was key. He wasn't able to go there on the fair and see the sunrise and do it by observation. He understood what was going on. So well done, William Stukely, and not so well done for John Smith for pinching the idea and getting it wrong. So it's all about the summer solstice sunrise, clearly. 40,000 people's the record. There we are, watching the sunrise out of the tip of the Heelstone, except it doesn't. In 2014, I spent about a week going to Stonehenge. I was working for English Heritage at the time, setting up my camera in the centre to try and catch that solstice sunrise without a whole load of people in the way. And this little video will show you what I observed. And just out of the tip of the Heelstone, you might just make out there's the sun rising. And I'm exactly on the axis here, exactly in the centre, looking down the primary axis of the monument. And I'd been after that shot for 14 years. Yes! But if we have a look at a close-up of that, the sun's coming out of the right of the tip of the Heelstone. It's not rising to the left of it. It's not rising out of the tip of it. It's appearing to the right of the tip. And the reason for that is twofold. One reason is that there's a whole bunch of trees on the horizon at Lark Hill now, and they're only about 50 years old. And about 100 years ago, when the military were first putting up their airfield on Lark Hill with their aircraft sheds, the private owner of the site, Edmund Antrobus, insisted that they leave a gap between the sheds so that it wouldn't interfere with the beams of sunlight coming down on the solstice to the monument. And the military were accommodating, and they left something which is called the sun gap between their aircraft sheds. Sadly, in the intervening 100 years or so, they've forgotten all about that. And those trees offset sunrise to the right. The other reason that it doesn't quite work is because there's been a change in the tilt of the Earth in the last 4,500 years. It's a very long cycle, it's about 41,000 years altogether. But if you go back to 2,500 BC, the tilt of the Earth was 24 degrees. It's 23.5 degrees today. And this change in the obliquity of the ecliptic is what shifts the solstice, sunrise, and sunset positions on the horizon. And note, that's not the precession of the equinoxes. I've heard astronomers call it the wrong thing. It's the change in the tilt of the Earth, not the rotation of the axis like that. So if you can wind back the clock to 4,500 years ago, and you were standing where I took that video, you'd see the sunrise to the left of the Heelstone, out of the true horizon. There's no trees there. It's a bare plain, and it would rise over the tip, and the sun at full orb, in its full majesty, the God is there in all of his power, is directly behind the tip of the Heelstone. And it's kicked off to the right today. So that's why it doesn't work. But you could say, why are we standing in the middle and looking outwards anyway? What happens if you stand over there, next to the Heelstone, instead of in the middle with 30,000 crusties like me? What do you see then? Terence Meaden's got it right. This is what it's about. That photo is taken about 15 minutes after sunrise on June the 24th, Gregorian calendar. And that is the shadow of the Heelstone. And 15 minutes earlier, without the trees on the horizon, and 4,500 years ago, that really strong shadow penetrates the centre of the monument through stones 1 and 30 and leads up and falls directly on the altar stone. And Terry Meaden's astonishing work with Stonehenge, Avebury and Drombeg has really brought to the public the idea that it's about the shadow play. It's about this sacred marriage between the sun God, the Father God, and the earth goddess. And Stonehenge, with its circular form and the internal horseshoe of trilithons, is the female, and the heelstone, or Mr. Pointy, is the sacred masculine. And so at the height of the sun's power, the shadow cast by the sun over the heelstone penetrates the earth goddess, and if you like, it's a sacred marriage, it's the ritual fertilization of the earth. And it works very nicely because 9 months later on is the vernal equinox when the world bursts back into life again. So that's key. Stand outside the monument and look into it. Not necessarily stand in the middle and look out. So returning to William Stukeley's idea about the avenue, that gets picked up in the early 20th century by two people, really. Sir Norman Lockyer and Alfred Watkins. And they both suggested that Sidbury Hill, not Silbury, but Sidbury Hill, is the foresight for this alignment, starting at Stonehenge, down the centre line of the avenue. So you can see Stonehenge here, and the avenue is extending in that direction. You just about make it out on the screen. And it extends across the landscape, that alignment to the midsummer sunrise, towards Sidbury Hill. Very large hill on the east of the Salisbury Plain training area, 732 feet tall. It's there in that shot. There it is in this shot. And here's the Ordnance Survey map. And it's a remarkable spot. There are 3 Bronze Age linear ditches that converge on it. There's a henge monument just off the map there. There is a very extensive Bronze Age burial mound cemetery called Snail Down with some astonishing barrows just over here. And the latest dig that's been going on in Bulford for some army housing that they're putting up has discovered scores of Neolithic pits with woodlands pottery contained within them and some green flint and a green flint working area. And the only local source for green flint is at the top of Sidbury Hill. So it looks very like this hill is important to people 4,500, 5,000 years ago, up to about 3,500 years ago. Sidbury Hill is significant in this landscape. And Alfred Watkins and Norman Lockyer suggested that this was what the builders of Stonehenge and layers out of the alignments were focusing on as their target when they laid out that primary axis. And Watkins actually says in the old straight track that the sun rises out of the southeast flank of Sidbury Hill, and that's the target. So back in 2006, I drew a line across a map of the alignment of the avenue, and I went up to Lark Hill, just where the aircraft sheds used to be. The sun gap is here. And I stood on the side of the road and I waited for summer solstice sunrise to see if it actually did. And yes, it does. It rises out of the southeast flank of Sidbury Hill. There's Sidbury Hill. There's the summer solstice sunrise. And if you take into account the change in the obliquity of the ecliptic, then 4,500 years ago, that is there. Sun, Mrs. Sun, sun. It's about a degree to the left, round to the north, 4,500 years ago. And that interested me, and I started to get a bit wound up about the idea of, well, what happens beyond Sidbury Hill? Does this alignment continue any further? And I prolonged the line on the map, taking into account the elevation of the horizon, and discovered that the alignment beyond Sidbury Hill intersects with a 5-way crossroads at Scott's Paw. And somebody knows this, because there's the alignment, there's a byway that runs along it, and the last 100 yards of that alignment is covered in sunflowers in the edge of the field. What more appropriate thing could you put in the landscape, in the side of an arable field, than a whole load of sunflowers on the summer solstice sunrise line? That's curious. Is it a coincidence? Might be a coincidence, we don't know. So here's the thing. The heelstone is the summer solstice sunrise marker. No, it isn't. It's offset to the east of the primary axis. The avenue aligns with the summer solstice sunrise. Yes, the centre line is that primary axis, and it's aligned on Sidbury Hill. And do the sunflowers mean someone knows that? Maybe. There's a plantation at the foot of Sidbury Hill in the direction of Stonehenge called Sun Plantation, so the names are important. Okay, so that's the summer solstice sunrise. Everybody knows about that, except we've all changed our minds now as archaeologists, and it's all about the winter solstice sunset, isn't it? Right, okay. This starts with John Wood about 20, 30 years ago, suggesting that the winter is the important time at the monument. Later scan data and analysis of the monument suggests that it's designed to be seen from the heelstone looking southwest. Okay, great. And these days, of course, English Heritage with interpretation officers have decided that 900 tons of rock in the landscape with a clear axis is not sufficient to point this out to people. So they've put a whacking great 10-ton bronze arrow in the middle of the old road, and one end's labelled summer solstice sunrise and the other end is labelled winter solstice sunset. Fantastic. So everybody can appreciate that. So I went out into the landscape up towards Lark Hill, and I thought, if I stand in the right place, I'm going to be able to see the sun drop, plop, into the very centre of the stones. And that would be a cool time lapse. So here's a cool time lapse. Stonehenge, come on. Come on. No, it's not going to play the video. All right, that's a shame. See if I can make that one work. That's unfortunate. Oh, it is working. Pop. Yay. Thank you. It's not quite right. That last gleam disappears behind the rocks of the outer circle there in our era. 4,500 years ago, that last gleam would be exactly in the middle. And it's the change in obliquity again that's made that shift. So you've got to factor this in all the time. So, summarise that. The avenue aligns with the winter solstice sunset. Tick. Last gleam falls between the uprights of the tallest trilithon, seen from the centre line. Yes, but only 4,500 years ago. Now, you might be interested in knowing where the winter solstice sunset line goes across the landscape. So there it is, Stonehenge there, Groveley Castle, Chicksgrove Manor, solstice alignment, Melbury Hill in Dorset, and the Cerne Abbas Giant. That's where that goes, just in case. So what about the moon? We've got the sun, we've defined the primary axis of the monument, and if we go back to Diodorus Siculus's quotes from Hecataeus, the moon appears very close to the island every 19 years, blah, blah, blah. And in the sort of mid-1960s, two people, Gerald Hawkins and C.A. Peter Newham, both working independently, arrived at the same conclusion. And that was that the station stone rectangle had something to do with the moon. And there's the station stone rectangle, 4 stones originally that surrounded the monument, with clear sight lines from one spot there, the North Barrow, across to this station stone, and from the South Barrow across the back of the monument to that station stone there. And it's only the latitude of Stonehenge, 51 degrees 10 north, that the extreme sunrise and sunset in the winter, and the extremest possible northernmost moonset and southernmost moonrise make a right angle. So the people who put this together, either it was a massive coincidence or they knew about these changing angles depending on what latitude you're at. So Peter Newham comes up with that, Hawkins comes up with it independently, and the archaeologists hate it. This is ridiculous. But in 2006, I bullied 6 of my friends to come with me to Stonehenge and stand in the North Barrow in anticipation of the southernmost maximum moonrise at the Lunstice. And sure enough, as you can see by this picture, every 18 years the moon rises over this gentleman. He would not get out of the way. But there is the station stone, there's the true horizon, there's the moon just above the cloud bank, and that's the track of the moon as it rises. Every 18.61 years, the long sides of the station stone rectangle tie in with that Lunstice position. Very interesting. And Peter Newham had another thought. he suggested that there's a series of post holes across the northeast causeway entrance to Stonehenge, and he suggested that they had a lunar function. This idea is picked up by Aubrey Burl, and these are the post holes that we're talking about. There's about 6 rows of them. There's the heel stone just at the top, and just to the left of the heel stone are 4 big wooden post pits, now unfortunately known as the A-holes. Right, okay. So that's Peter Newham's drawing of them. And he's suggesting that the heel stone marks the midpoint of the moon's swing between the minimum major moonrise and the maximum major moonrise in the north, the wintertime moonrises. The station stone rectangle is here, heel stone is there. That's the northernmost moonrise you can ever get, to the left of the heel stone by getting on for 9 or 10 degrees. So if we have a look at a slightly more complex diagram, there's the station stone rectangle, there's the heel stone over there. What's going on in here in the northeast causeway entrance with those post holes and with the A-holes over there? I hate the name A-holes. Let's have a close-up. There we go. So we draw a line from the center of the Aubrey hole circle, and we join it up with those 4 post holes there. There's the heel stone. And we read off the azimuths for them. Those are what you get. And Newham and Burl both suggest that this operates as a countdown year by year to the northernmost moonrise. And essentially, if you're standing in Stonehenge at the winter solstice nearest full moon and you look out over the heel stone, you will see the moon rise somewhere in this arc in its 18.61 year cycle. And there's a countdown. So 5 years before, 4 years before, 3 years before, 2 years before, 1 year before, and then the year of the major moonrise to the north is there, 4126, thereabouts. The moon is maddening to try and calculate its positions. It's not simple like the sun. It's a lot closer than the sun, so you have to take into account parallax as well as refraction. Even with the best iterative calculations that we could do today, moonrise times, accuracy, 2 or 3 minutes, position, difficult to pin down. That's close enough. If you do the calculations, it comes out at about 40. If you take into account parallax, it comes out about 41 and a bit. It's certainly plausible that those A posts, he said carefully, are that countdown. 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you've got a swing across there with the heel stone being the center point. If you've got a handle on that 18.61 year cycle, you've got a handle potentially on how to predict eclipses. So does Sidbury Hill play any part in that lunar alignment, the northernmost? There's Sidbury, smashing place. So I went back in 2006 at the major northerly moonrise in August, stood on the same spot in Lark Hill where I'd taken the summer solstice sunrise position over Sidbury, and I took a photograph of the northernmost moonrise. Ta-da! There it is. You can't see a bloody thing. However, if you do a bit of processing and you overlay it, there we go. There's Sidbury, there's the solstice sunrise, there's the northernmost moonrise. Factor in obliquity. That goes that way, that goes that way. Sidbury is the bracket that defines the span of how the gods behave 4,500 years ago. That's really interesting. That's a significant spot. It looks to be targeted. It might be something to do with why Stonehenge is where it is. Certainly they understood all of this. The ancients are very clever people, cleverer than us. As a little aside, what else is going on over here? Now, a friend of mine called Peter Dunn, who used to be an illustrator for English Heritage, did a lot of the visualizations and reconstructions in an earlier version of the guidebook. He's been looking at plans of Stonehenge for years. And he noticed something very interesting. This is unpublished, but he's given me permission to tell you about it. If you strike an arc, radius the length of the station stone rectangle, from the station stone, and like that, that arc goes right through all the big post holes across that northeast entrance. There's been an argument forever about what phase the station stones were put up at Stonehenge. Are they part of the later phase with the big rocks? Are they part of the early phase with the Aubrey holes and the bank and the ditch? We know these post holes are part of phase one. We know that the A posts are part of phase one because they're contained within the boundary of that northeast causeway before it's enlarged when the big rocks arrive. Peter spotted that, and then he started drawing arcs from everywhere. And it turns out that arcs that you strike from each of the station stones with that radius define the entire geometry of the site. It embodies a vesica piscis, like this, which gives you the terminal of the ditch. It gives you the position of the heel stone, bank, and ditch. So the station stones define the geometry of the very first part of Stonehenge, 5,000 years ago, in conjunction with two post holes, one there and one there, that are directly in front of the altar stone. And those post holes and the altar stone are not perpendicular to the main axis. They're at a different angle. We'll come back to that. I think Peter's onto something there. I think he's shown that the station stones are part of the first part of Stonehenge, not later. And that means that the moon is part of the first phase of Stonehenge. The earthworks are part of the first phase. They're targeted on the moon. There's the summary. The primary axis is solar. The primary axis of the earthwork is lunar. And back to the sun. So, we've got a primary axis, summer sunrise, winter sunset. What about the other way around? The notch. If you stand on the visitor path on the west of the monument and you look through the monument, you'll see that there's a little notch in the edge of stone 58 there. There's stone 58. And the edge of that notch where it's open is closed up by the edge of stone 53 on the far side of the monument. And that's targeted on the horizon of Coneybury Hill. And remember that electricity pylon, if you can just about make it out. It's a useful feature, not Neolithic. That is a very, very tightly constrained sightline. We start over here on the visitor path. The notch is in there. The edge of the stone is there. Over stone 8's edge and off towards the horizon. If you stand on that axis at the winter solstice sunrise and you're looking in the right direction, you see that. That's winter solstice sunrise 2012. There's the electricity pylon we saw through the notch. And we've got to take into account the change in obliquity of the ecliptic. And 4,500 years ago, the sun rose. One sun, miss a sun, there's the other sun. That's the position of sunrise 4,500 years ago at the winter solstice sunrise. Ignore the calculations, that's just me being obsessive. There's your pylon, there's the sun today, there's the sun when Stonehenge was built. And if you put that on the notch, it's targeted like a rifle sight on it. And this notch shows some evidence of being tooled. Originally, it's a natural fracture in the rock, but it looks like it's been shaped out. And this is noticed by a chap called Professor Gordon Freeman from the University of Alberta. He did a lot of work with a medicine wheel in Alberta called Old Big Rock Arrangement, which is 7,000 years old and targeted on the solstices. He published a book called Canada's Stonehenge. The second edition is called Hidden Stonehenge. It is without doubt the only book on the astronomy of Stonehenge done by somebody who knows what the hell they're talking about. He went there, he looked at the shapes of the stones, he looked at the landscape form, and he drew conclusions from observation, not from just lines on a map. Get a copy of Hidden Stonehenge, it's fascinating. So if you stand outside the monument and look along that notch alignment, there's the winter solstice sunrise through that notch in our era. It's an esoteric alignment. You need to know where you're going to be able to observe that. It's non-obvious. And if you turn around and look in the other direction across the landscape, you get this massive shadow of the stones, and barely you can just make out there's a beam of sunlight that's coming through the notch and running across the landscape in the direction of Fargo Wood over there. And it's probably a coincidence. Surely it must be a coincidence. If you follow that line for 262 miles, you go straight down the passageway at Newgrange. Oh, and I mean exactly. Are they doing long-distance survey between monuments that are separated by that sort of distance and in time between 3100 BC for Newgrange and 2500 BC for Stonehenge? That's something that archaeologists will hate. So if you're going to extend the sunrise line, you might as well do it for that direction as well. Why not? I've got nothing else to do with my life. So here we go. Stonehenge is in the top left-hand corner. There's a bit of a blow-up. There's the line as it runs across the landscape. It diverges because it diverges. Yeah, if you stand there, it's slightly bigger. That's what 1 degree expands out to, as you half a degree expands out to as you stand at Stonehenge and look over there. Coneybury Hill is this bit. The electricity pylon is down there, and this line tracks across the landscape. And I decided I'd work out where it was going to go through after about 8 miles, because that's the distance from Stonehenge to Sidbury Hill. I wondered if there was anything interesting in the direction of the southeast. So I took into account the elevation of the horizon, which can kick off the direction of sunrise. Luckily, it doesn't bother it too badly in this direction. And sure enough, after 8 miles, it goes through, interestingly enough, the parish of Winterslow. There's something in a name. The 3 settlements of Middle Winterslow, West Winterslow, and East, collectively named in the Domesday Book as Wintersley, or Ley, meaning Winter's Mound or Burial Place. That suggests that this area is named in relation to Stonehenge, because this is where the sun rises on the day that it dies, prior to being reborn for the start of the next year. I think that's interesting. Let's have a look at the folklore. There's a tradition of a buried golden coffin in Winterslow. Anything buried in golden's always the sun. And there's a nice barrow there, smack in the middle of the alignment, which is lovely. Anyone for an Orion correlation theory? That's just coincidence, surely. And I could have saved myself an enormous amount of effort, calculation, getting up at ridiculous hours and tramping across landscapes to stand on hills in the fog, waiting for sunrise for years and years, if I'd just drawn a straight line across the map and looked at the place names, because smack bang next to it is the farm of Midwinter. Somebody knows what's going on. The people in this area are the descendants of the people who put all this landscape together. The folk memory somehow is persistent. Yeah? We tend to overlook it and we ignore it. So that's an interesting alignment. Now, the reverse direction of the winter solstice sunrise is, of course, the summer solstice sunset, and it's exactly in the opposite direction. Notch is there, edge of the stone is there. We were looking that way for the winter sunrise. We're now looking this way for the summer sunset. And it should be setting into that notch again. So there's the summer solstice sunset line, and the notch is there, slightly obscured by the remains of the collapsed tallest trilithon. That's its lintel, that's the upright, both badly degraded now. This is the edge of stone 53, the one with the daggers and the axes on it, the really big ones. There's the notch. So does the sun set into that notch on the summer solstice sunset? Of course it does. There it is. Barely seeing it there, just about see it there. There's the notch. I'm slightly off axis to take account of the fallen bits of trilithon, but 4,500 years ago, standing in the right place, So those two axes intersect in the center of that monument at an angle of 80 degrees. There's the primary one, summer sunrise, winter sunset, winter sunrise, summer sunset, and they intersect in there. And if we just look at that on a slightly different plan, there they are. Heelstone is over here on the top right. They intersect at 80 degrees. At this latitude, the angle between summer sunrise and winter sunrise is 80 degrees. And they intersect there, exactly over the center of the altar stone, which remember I said isn't perpendicular to the primary axis. It's at 80 degrees to the primary axis. There's been an argument forever about whether the altar stone used to stand upright or was deliberately placed flat by the builders. It's a unique stone. It's not from the Preseli Mountains. It's not from the Marlborough Downs. Recent suggestions in the geomorphology of it and the chemistry suggest that it's more likely from the Brecon Beacons. It's a unique, nice, green, glittery micaceous sandstone. Post holes there and there that define the axis of the first monument and the lunar and solar elements. The long axis of the altar stone lies directly on the secondary axis discovered by Gordon Freeman. Well done, Gordon. Is there anything else in the Stonehenge landscape which has an angle of 80 degrees associated with it? Well, yes, there is. There's the fabulous treasure of bush barrow. This is the bush barrow lozenge. It comes from Normanton Downs Cemetery, excavated in 1808 by Colt Hoare and Cunnington, and that angle is 80 degrees. This is beaten gold. It's 1 millimeter thick. To mix my units, it's about 7 inches from there to there. The lines inscribed in the surface are essentially the width of a human hair, and they don't miss each other in the corners. They're absolutely perfect. It's a work of genius. It's in a burial of somebody who we probably label as a shaman, though that's a very heavily overloaded word. The person in that burial mound dates from about 1900 BC, so 600 years after the big rocks are put up. They still know what it's about, this 80-degree angle, because you drop that smack in the center of Stonehenge, and it works perfectly. The ancients knew what they were doing. So that's the sun, and that's the moon, and if you've worked out what they're doing and how they're behaving, then, and you've got an idea of this 18 and 2/3 year cycle called the regression of the lunar nodes, then you can start to think about eclipses. That's a photographed time-lapse montage of the near total solar eclipse over Stonehenge in 2015. Beautiful. There's the monument in the bottom. All the world's press has stood there, which is the wrong place. Serves them right. Gerald Hawkins comes up with the idea that 56 Aubrey holes can be used to track the movements of the sun and the moon and their crossing points in the sky, and he publishes it in Stonehenge Decoded. And he comes up with the concept of eclipse seasons. A few years later, Fred Hoyle, also an astronomer, refines that slightly and comes up with a more simple way of moving your markers around the place. And just because I'd never actually tried this, and I thought that you may not have tried it either, I thought I'd do a little sort of worked example of how it actually happens. So here we go. Here's a plan of Stonehenge, and you've got to imagine Stonehenge represents the Earth. So we've got a whacking great Earth in the middle. And you've got 56 Aubrey holes that go around the outside, and they represent the sky, divided up into 56 bits. And all you need are 4 markers. You need a Pax Robin Heath. I know I'm going clockwise, and you go anti-clockwise. It doesn't matter. Sun marker, a yellow blob. You move it 2 holes every 13 days. And it goes around once in 364 days. So the sun goes around the sky once a year. Close enough. The moon, you've got another marker, and you move that 2 holes clockwise every day. It goes around 56 once every 28 days. Close enough. It should be 27.3, close enough. And you've got markers for the crossing points of the sun and the moon in the sky called nodes, and you move them in the opposite direction 3 holes a year. And that means that they go round those 56 once every 18 2/3 years, which is actually pretty accurate. So with 56 holes and 4 markers, you can track to a reasonable degree of accuracy the movement of the sun, the moon, and where they cross in the sky. And it's important about the nodes to realize that you can get eclipses not just when the sun and the moon are exactly on the node or opposite each other, but you can have them either side as well. So you've got a zone where you've got a chance of an eclipse. And it works out to being 1 Aubrey hole either side of the position of where the node markers live. So let's work it. Here we go. Here's a nice picture of some people in tinfoil hats come to observe the solar eclipse in 2015. There's a nice picture of the near total eclipse over there. March the 20th, 2015. Sun and the moon are both in an Aubrey hole together. They're both within this zone of eclipse next to a node marker. The nodes are always opposite each other. Let's start moving them and see whether this actually works. So, March 21st, we've moved the moon marker 2 holes. So it's going to go around once every 28. And we'll keep going, 22nd, 23rd, 24th, 25th. This goes around clockwise rather than Robin's anti-clockwise because I did these animations for the BBC and trying to get them to get their head round anything was a challenge. Clockwise worked, so that's why it's opposite to Robin's. 26, 27. Oh, right, time to move the sun marker by 1 hole. Move it by 1 hole after 7 days, and by another hole after a further 6 days, 2 holes every 13. That gives you 364 days to go around once. Quite confusing to keep track of. I found myself at 6s and 7s about that. Let's keep going. Moon's carrying on. 28th, 29th, March the 30th, April the 1st. No, sorry, March 31st. Sorry, lost a calendar day. April the 1st. Time to move the sun again. Okay, so it's moved from there to there. April the 3rd, April the 4th, this is the full moon. The sun and the moon are directly opposite each other in the sky. They are both within the zone of eclipse, 1 Aubrey hole either side of a node marker. This Aubrey hole calendar predicts that there will be a lunar eclipse on April the 4th, which is clearly nonsense. Oh, no it isn't, it works, it's perfect. Yeah? It turns out you can cope with the inaccuracies, the 364 rather than 365.2522, and the 28 versus the 27.3, because you can correct the moon's position once a month at full moon, put it directly opposite the sun marker, and you can correct the sun's position twice a year, summer solstice sunrise, winter solstice sunset. So you can cope for these. And I believe I remember reading somewhere in Robin Heath's work that he's operated one of these for a number of years and been able to keep track of eclipses to the day. It does work if you pay attention. And of course, archaeologists hate this. They loathe the idea. And the renowned archaeologist from the 1950s who did probably the worst archaeological dig ever carried out inside Stonehenge, which was never recorded properly, never published, but he was a luminary at the time, a chap called Richard Atkinson, said, the people who built Stonehenge were howling barbarians. He looks the type. If 56 was a significant number for eclipses in the ancient world, we'd find evidence of it everywhere, or elsewhere at least. Yeah? And we don't, is the implication. He had a right go at Hawkins in a paper in antiquity called Moonshine on Stonehenge, where he utterly rejected this idea of accurate astronomical observations being carried out by people who were howling barbarians 4,500 years ago, completely failing to take into account the fact that humans have been watching the sky for at least 80,000 years, arguably longer, and that the oldest lunar markings that we have anywhere at present that are accepted are on a bone from central France that's 35,000 years old. We keep track of this stuff. The sky's up there. It's the only thing in our environment that we can't go over and touch. If there's an island over there, you can build a boat, get on the boat, go to the island, and touch it. If there's a mountain, and it's a long way away, you can walk to it, climb up it, and touch it. No matter where you go and how far up you go, you cannot touch the sky. Dragging the sky down to the ground and marking it and understanding how the sun and the moon, the major luminaries, are behaving, and being able to keep track of when they're likely to behave oddly, and lunar eclipses are key to this, because they're very much more obvious than solar eclipses. This is something fundamentally human. It's what we want to do. It puts us on a level with the gods. So, of course, Atkinson, nonsense. Subsequent to all of this, it turns out that we've known this for ages. Plutarch, in the 2nd century AD, in writing of Osiris and Isis, says the Pythagoreans clearly believed Typhon to be a demonic power. The 56-sided polygon is said to belong to Typhon, as Eudoxus has reported. And there are some who give the name Typhon to the shadow of the earth into which they believe the moon falls and so suffers eclipse. Eclipse 56, 2nd century AD. There is evidence of it in the literature. It's just that astronomers and archaeologists don't tend to read Plutarch very often. So there's a total lunar eclipse of September 2015, and there's Typhon. The 56-sided polygon is sacred to that. So is there evidence of 56s elsewhere? Is it just this single occurrence of Aubrey holes and Plutarch's reference there? No, there isn't, because Alastana in Sweden, stone boat, 56 stones, plus 3 for prow, mast and stern, has also got 56 in it. Not only that, it has been constructed at the precise latitude where summer solstice sunrise, winter solstice sunset line, and the secondary axis form a right angle. So this is 80 degrees at Stonehenge, it's 90 degrees if you go to Sweden. Are these people howling barbarians? No, they're not. It's not about the rocks in the field. The rocks are the vernier that you look through. The landscape has got the names, it's got the associations, it's got the reverence. The whole of the landscape is sacred. Before we become mechanized human beings, the entire landscape is sacred. Waterfalls, trees, rocks, bend in the river, you name it, they're all sacred. This is a songline landscape. We've just forgotten the words. Thank you very much, everybody, for listening.